or by someone else using that system while he is testing it out. Okay, so let's quickly just list down what are the different types of constraints that we have on this graph sort of figure out here, and see how we can get past this. So what you see on the right side is the physical test environment, and these could be servers. We said physically it could be a server. In terms of software, it could be a web service running on that server. And I might have maintenance constraints on that. I might have a physical system such as a mainframe where I have a limited access period on it. So I could be either constrained by the physical system itself or by the software that's running on it in terms of messaging queues. I might have volume constraints physically posed by a smart device, and through software maybe input-output is what the volume constraint is caused by. I could have a back-end database system, and I might have volume constraints on this database system. So when application virtualization comes into the picture here, what happens is we put in an agent that can listen and capture the interactions between the system under test and those backend systems that we are constrained by. So once it can listen and capture, it would primarily look at the request response sort of messages or whatever publish messages that take place between the system under test and the backend system. It can then choose to store that information in a configuration management system, in a source code management system, or it could model certain services out of that information. So when we say we are modeling services, the services that we mention on the backend systems are the web services, the messaging queue or the fixed services, the smart device I/O services, or the database transaction services, right? So we can model these services based on the information that we captured and host these services on virtual environments and then use them for testing. Now, going one step further, what we can then do is we've created virtual services. Now, these virtual services can be deployed by each team or by each developer or tester on his or her individual machine or individual testing environment. And then we can choose, as our backend systems get ready or as our backend systems start becoming less constrained, to convert these virtual services to the actual live services, right? So I might have my functional testing team that wants to have certain specific configurations for their virtual services. So they might want to test with certain IP addresses and certain proxies and with certain database configurations, while my system integration test team might want to test with different configurations, right, for their databases, for their other systems. It's possible for all these teams now to simultaneously test with their different configurations using different instances of the same virtual service. They can duplicate the virtual service that was created by the agent that we deployed in between the system under test and the backend system, configure it according to their needs, host it on their individual environments. These could be virtual environments, because these could be physical environments, and simultaneously test. So while a developer can start his integration testing at the time of coding, a functional test team can pick up the code that has already been delivered and run tests against that code against virtual backend systems. And while all this is happening, the system testing team can also pick up whatever is currently available in terms of an end-to-end test, run the tests against virtual service backend systems, and look for early signs of breakages in an end-to-end scenario. And since this is already possible now, we can also start doing some amount of performance testing right away in order for us to identify issues with our design that might be causing performance hits, right? So what we've done essentially is that we've removed the big bang where multiple developers were trying to put in their code together without any integration testing. We are introducing integration tests at the time of unit testing, which means developers start doing integration tests, or integration tests are run automatically through nightly builds while unit tests happen. And we're moving back the entire cycle of testing significantly earlier in the cycle, which means then performance and all the other tests can start much earlier than before. So what does this do? It accelerates testing, obviously, because we started testing now much earlier than we were before. That causes a reduction in cost,